Thank you for inviting me. Lovely to be here. My name's Nigel. I'm going to talk to you a bit about Neo4j and how we can work with that from Python. It's nice to be here in the just after lunch spot, so I'll try to be extra specially interesting so that nobody falls asleep. Right. Let's talk a bit about who I am and what Neo4j is. So my name's Nigel Small. I'm the driver technology lead at Neo Technology. I'm behind the bulk binary protocol that we introduced with our 3.0 version last year, and the official drivers that we launched. Prior to that, we just had community drivers for our HTTP interface, but we've now developed official drivers for Python and some other languages that you're probably not very interested in. I've been at the company for 2.5 years, but I've been involved in the community since the middle of 2011 in a very Python overlaps with Neo4j kind of capacity. I'm a multi-language programmer historically, but most at home in Python anyway, so it felt like a good place to come and be amongst friends. Neo4j is a graph database management system. So where you're used to storing data in tables, we store data in graphs instead. Neo Technology itself is based all over the world. Main engineering office is in Sweden, although we have a London office and an office in California as well. Started life as an embedded Java, I won't say the Java word, sorry, the J library, and it's now a fully blown database product with everything you'd expect from a database. Cypher is our query language, so where you'd normally be using SQL when you're working against tables, we've got Cypher instead, and I'll go into a little detail about that later on, but the whole thing is open source on GitHub, so there's a lot you can look into there. If you want to play around, you can go to a download page. We've got distributions in a number of different formats. Good point, thank you. We've got distributions in a number of different formats. So we've got our tarballs, as well as Debian packages, Windows packages, and everything else as well. Very easy to get up and running. And we have a browser component which lets you run queries and visualize the results nicely, which lets you explore a data model. So, the Neo take on a graph, what does it look like? Well, we have our nodes, which are the vertices, we call them nodes, and they represent the objects in your domain that you're trying to model. So here we're modeling a couple of people, a couple of person nodes, and a car. And the relationships between those are defined as the connections that have a direction, have a type, and may also have some set of properties on them. The properties on the nodes are really where you're storing the data that you're interested in playing with. So for a person node, you may have a name, a date of birth, a Twitter handle, and so on. And the name value pairs that we have are things that must adhere to the Cypher type system, which we can look at a bit later as well. So Cypher is a declarative language. It's based on SQL, so if you've used SQL, which obviously most of you have, it'll be very, very familiar. But its real selling point is that it has a capacity to match patterns in graphs in a very visual way. We use an ASCII art syntax for that. And it will look a bit like this. So if we want to match a couple of nodes together with a relationship in between them, we'd create a match clause. The nodes would be represented as items within the round brackets, and we draw an arrow between them with a square bracket identifier for the relationship type. Within the round brackets, then we're looking at nodes that are with a label person, and a node can have one or more labels attached to it. They're like tags. They're sort of akin to table names, I suppose, in some ways. But more so where you can have multiple ones. Somebody could be a person and an employee and female, whatever you wanted to put in there. The relationship type, then there's exactly one of those. So in this case, we're matching a loves type. And then the properties themselves can be included within the node notation if you're doing an exact match. Overall, to run a query, you'll piece together a number of clauses. So there'll be one or more match clauses typically, where you can match one of these ASCII art patterns. You can filter those with a where clause, where subclause. You can add some optional matches, which are kind of equivalent of a left join, I suppose, in table world. Then there's a with and return clause that you'll be interested in. The return is the equivalent of your select, but it goes at the end, and it will select things out of the patterns that you've matched and allow you to return them. And with allows you to chain several sets of matches together. If you're doing several layers of aggregation, for example, you may want to use that. And then order, by, skip, and limit should be familiar for anyone familiar with SQL. So from Python, how do you then use this? Well, we've got our official driver, the Neo4j -driver package on the Python package index. Once you've got that installed, you can import the graph database object, and that allows you to create a driver which you can connect to a database running on a particular machine with some authentication details. Very straightforward. And then you create a session, and your session is a context for running several transactional pieces of work. Session run will let you run a very simple auto commit transaction, and here we're just generating some values. We're not actually touching the graph in this particular example, but we're returning an integer, a boolean, and a float, and calling them A, B, and C. And then out of run you get a result object, and the data method on that is one that will be really interesting for anyone who wants to integrate with something such as Pandas, where you can just collect up your entire result and return it as a list of maps. You'll typically want to parameterize Cypher when you're using it. So where you can, if you want to, write a statement like the one at the top, where you're matching on an exact name and exact string there. Typically, you'll want to use that in with the substitution parameter in that spot instead, and pass in a set of parameters to substitute. And the reason for this is that the Cypher engine that receives it will be able to optimize if it sees the same statement coming in more than once, the same exact string. So you may be searching for Alice, you may be searching for Bob and somebody else later on. The Cypher engine will only have to compile that once. When it sees an exact match for the string, it will retrieve the compiled version, and you'll generally get better performance overall. Results out of the other side a result is a stream of records. Each record is, as you'd expect for a record, it's ordered and it's a keyed set of values. And then the values themselves adhere to the Cypher type system, which looks a bit like this. So you can have null values, and interestingly, we don't have a specific difference between what is a null value and what's actually missing from your set of key value pairs. So if you're missing a property within a node, say if somebody doesn't have a date of birth attached, then you'll get a null back. Null and missing are treated identically. They map to none, obviously, in Python. Booleans, integers, floats do everything that you'd expect them to do. Strings map to strings, or Unicode if you're still running Python 2. Lists are lists that map to lists, maps map to dictionaries, and then we have a few graph structure specific types. You can actually return entire nodes, relationships, or a full path, which is a history of a walk through a graph. You can return those back in queries as well. And typically you might be interested in doing that if you're building some form of visualization, or you want to get a whole set of data and want to later do some other things with it, drilling into the data within that. So I'm going to try to demo a little bit. We've got a data set that we've taken out of Yelp. If you're not familiar with Yelp, it's a business review site where you can review bars, restaurants, and so on in various cities around the world. And they have periodically they drop a set of data onto their website that's made available for a data set challenge. We've picked up those, and they come in CSV format. We've translated them into a graph, and it looks a little bit like this on the meta level. So we have users. Users can be friends with other users. They can write reviews. Reviews are about a particular business, and businesses fall into particular categories. So I'm going to switch over to try to show you how this might look. Here we go. So here's some code. This first bit of code, we probably can't see that. Let me blow that up a little bit more. Try to fill the screen. It's a little better. Can everybody see that? Yep. Cool. So what we're trying to do here is simply connect to the database and begin a session to carry out some work. So I'm pulling in the graph database object from the Neo4j driver. I'm pulling in a Pandas data frame, and I'm creating a driver instance. So here we see we're connecting using the Bolt protocol to a database I've got running on localhost. The default port is 7687, and the authentication details are there. So we've got a very secure password there, obviously. It's running localhost, it'll be fine. We then create a session. So this is our container for our work. So if I run that, we get nothing out of it. It's nothing interesting to see at this point. But we can start looking at how we might run some Cypher. So we want to match some nodes. And here we're basically matching a selection of 10 businesses in Edinburgh that have at least 100 reviews on them. So we've got a match clause here. We're matching business nodes. We're filtering by city, and we're filtering on having a review count of at least 100. And then we're just returning a set of properties that we're interested in. So the name, the city, the review count, and the number of stars, and limiting to the first 10 of those. So we can see we get out a nice table, and I've wrapped this into a data frame to output because it gives a nice tabular view. The data method there again, as I mentioned earlier, will let us take this entire result and do that very simply. So we're seeing what we'd expect to see, a set of businesses and the things that we've asked for. We can similarly match some relationships. So here we're matching reviews that are on a business again in Edinburgh, and we're looking for the funniest reviews and listing the top 10 of those. So we'll see the match pattern here is a little different. It's matching two nodes with a reviews link in between them. We're again filtering by city here, and we're returning the text, the funniness level, and we're ordering by the most funny, and again we're limiting to 10. So we can see there a straightforward table coming out of that. Aggregation. So in Cypher, group by is implicit, so everything you're not putting an aggregation function on will be grouped. So here we're looking at the total number of reviews and the average star count for a selection of 10 businesses. It's kind of just a random selection in this case. And we're doing a match on all businesses. We are then taking those businesses and doing some aggregation work on them. So we're doing a sum on the review count, taking an average of the number of stars, and we're grouping by city. As I say, there's no explicit need for a group by clause there because it works it out for you. We're then filtering those aggregated results, so this is the equivalent of a having in some ways. And then we're returning those values out the bottom. So that should give us exactly what we expect out the bottom. Now the API itself has more capability than just being able to run simple queries. We've introduced recently what are called transaction functions. So these allow you to wrap up a unit of work into a function object and use the session.read transaction method, which is this one here. And similarly, there's a write transaction method, and that allows you to take that unit of work, pass it in. It makes the code more reusable. You've got your unit of work that you can use in various places within your code. It creates a nice separation between your application logic and your database logic. But it also unlocks a retry capability that we've built in. So if you're using a cluster behind the scenes, we can replay that unit of work we can play it first of all on one cluster member. If that fails, if we get a connection error or some form of transient error, then that will be automatically replayed on one of the other cluster members. So you can take away some of the worry about running things, having to manage that yourself, that is. So here I've got a couple of transaction functions. The first one is very straightforward, count of the number of user nodes that I have in my database. Out of the run method again, we get a result as we'd expect, and there's a single method that you can run on that result. That'll take the first record out of the result and generate a warning if there's anything more that's returned. Typically, you'll use this where you expect there to be only one row returned, and if anything else happens, then it's a bit of a problem. And from that record, we're simply extracting the first value that we get back. This is a straightforward count query. And then the second transaction function here does more or less the same thing, but will, hang on a minute, it would do if I didn't change it as I'm highlighting it. It does the same thing, but it does a filter on name first. And we're passing that name into the transaction function. And you can see here when we call it, we can just pass a set of arguments. And the arguments and keyword arguments that you pass into this method are passed into the transaction function itself. So if I run this, I'm counting the number of users in my database, and I'm also counting how many of those are called Nigel. It's a very popular name, as you can see. So we've got 1 million users, 53 of them called Nigel. I've only ever once worked with another Nigel, and he was the imposter, definitely. So if I jump back to the slides here, some more fancy patterns that we might want to explore, and these are called friends of friends. So this is something that Cypher is very good at. It's very expressive, and something that you might not be able to do so easily in the world of tables. So the first example there will simply look for anyone who has a friend called Dave. There's a simple relationship from one user to another with a single hop of a friend's relationship. The second example then does 2 steps. So it's looking for someone who's got a friend called Dave. Regardless of whether you have a friend called Dave as well, you might know someone who does. Generally, everybody has a friend called Dave in my experience, but that's because I'm in Britain. It's probably a less common name elsewhere. The third example is a rewrite of the second example. This does exactly the same thing, and it collapses those 2 friends relationships into a single relationship that's times 2. So we're looking for 2-hop friends relationships. And all of this is reasonably straightforward, so you'd probably be able to do this with a couple of joins in most table-based databases. But the one thing that then becomes easier if you want to match variable length relationships. So the fourth example shows you how to match anything between 1 and 2. So if you know someone called Dave at depth 1 or 2, or going further, obviously, you can solve things like the Kevin Bacon problem, where you can see how far away you are from a particular person. Yes.
Is there a particular reason for the 2 brackets in the second row?
This one here.
Yeah.
Oh, hang on a minute. Yes. the two round brackets, the 2 parentheses. You mean? Yes. Basically, that draws an empty node in the middle. So you're always going to be hopping between a node. Yeah. Relationships can only join nodes. They can't join other relationships. So we're just drawing an empty spot in the middle. But the third form there that you see collapses that, so you don't even have to worry about that. The bits that you put in brackets can actually hold a number of things. So they can hold an identifier for that node. Here we'll see A and B are identifiers, and they're identifiers that are only relevant within that query. They hold no permanent meaning within the database. The labels are the things that follow the colon, so you might have colon user, colon employee, colon something else. And then obviously the curly brackets can contain the properties in there. But if you have none of those, you're not interested in those, then empty brackets are perfectly sane syntax as well. So in the browser, just to illustrate that quickly, you can see I've run a couple of these. So actually, if I scroll down to show you the first one first, I'm only limiting here because I've got 1 million users in the database. JavaScript's going to scream at me if I try to run all of these in the browser. So I've limited 5 here. You can see I'm running the match here for user to user with 2 hops. Again, filtering by those who know someone called Dave. And at the start here, you'll see this p equals, which is where we're taking the entire path that we've matched and returning that. So the return p will return the entire path object. So that's the nodes and the relationships and everything that makes that up. And then in this in this representation, you can see there's a few people there who know a Dave at length 2, and the people in between them. And similarly here, I'm doing the same thing for anyone who knows a Dave or knows who knows a Dave, which makes no sense. And you can see here we've got a similar set of data. So very useful for those kind of things that you wouldn't necessarily be able to do so easily in a table. So if you've tried this and you're getting stuck with anything, there's lots of places you can find help. We've got a Cypher ref card online, and this gives you some snippets for how to use each of the Cypher clauses that are available. You can do more than just reads. I've only mentioned reads here today, but there are a whole set of clauses for doing creation and deletion and merging and so on and so on. There's a lot more richness to it than I've mentioned. So hop along there and you can see a very easily digestible page. We have some language guides for working with the drivers, so Python and the rest of them are all on there. And there's the official driver. There are obviously a load of community efforts around that as well. So you'll see a lot of interest in Python. And we have some mailing lists that you might be interested in joining. A Slack channel, which is now got a huge number of people in it. And so you'll easily find somebody who will answer your question if you're stuck with something. And there's a group email address you can drop us a line at if you want to as well. And I'm on Twitter, on TechNige, so if you want to find me there. And that's it. Thank you very much.